Let's talk about solving logarithmic equations. What we're going to start here is with kind of a simpler form that if you happen to have this form, it's a really nice way to go about it. But most often we'll have these more complicated forms down below. But let's start with this kind of nice case where you can set it up so that you have logarithm equals logarithm. And what's going to be key is that they have to be the same base. So in this example, I have log base 3 of 2x minus 1 minus log base 3 of 4 equals 0. Now what we're going to do in steps below, and we could absolutely apply that to this scenario as well, is we could work on condensing this to a single logarithm. I'll kind of divide my paper in half. We can come back to this one with the steps from down below once we solve this. But what's nice about this is that if I added log base 3 of 4 to both sides, I would have log base 3 of 2x minus 1, and then equals log base 3 of 4. Now because they have the same base, what should happen here is that the value inside the logarithm should be exactly the same for this to work. So what's nice about this scenario is that we could actually take out the logarithm part of this and just say for this to be balanced, we would need 2x minus 1 to equal 4. So we can just focus on setting the inside of the logarithm equal to each other. So now I would just solve, add 1 to both sides, so 2x equals 5, divide both sides by 2, so x equals 5 halves. Or 2.5. And then what we could do is double check it. Let's go to the calculator. Now checking, we're going to need to use that change of base formula because we have a base 3. So let's see, this one would be let's go natural log, and then 2x minus 1, so 2 times 2.5 minus 1. And then I need to divide that by natural log of 3. To make sure that works out, to have that base of 3. And then I'm going minus, and then log base 3 of 4, so I'm going to do natural log of 4 divided by natural log of 3. And look, my calculator is giving me 0, which matches up with the setup of our equation there. So I know it all works out if we plug in that 2.5. So this specific scenario works because we could set it up to log equals log, and we have base 3 for both of them, so then we could just work with the insides of the logarithms. So what if that is not the case? Then what we need to do is follow these steps. So first thing we're going to do is condense, and actually let's follow these steps with the question we just did there. So with our case, we have subtraction between two logarithms, so what we could do is condense it to a single logarithm, so log base 3 of, and then 2x minus 1 would be the numerator, 4 would be the denominator, and then we want that to equal 0. So we condense, so we have a single logarithm. If we need to, we would take steps to isolate the logarithmic term. So in this case, I would be trying to isolate log base 3 now that I have a single term. It's already isolated, but if I had anything multiplying outside or adding, I would want to move anything else to the other side of the equation so that I just have log equals and then whatever's on the other side of the equation. Then we're going to change to exponential form. So I have a logarithm base 3 of 2x minus 1 over 4 equals 0. So we have base of 3, exponent of 0, and then this value of 2x minus 1 over 4. So we're going to have this value of 2x minus 1 over 4 equals base 3 exponent of 0. And if we have an exponent of 0, 2x minus 1 over 4 equals 1. And now we have something without any logarithms, and we just go through solving like we would, in this case, a linear equation. So I'd multiply both sides by 4. So 2x minus 1 equals 4, which actually takes us to exactly what we were solving over here. But add 1 to both sides, 2x equals 5, divide by 2, x equals 5 halves, or 2.5. So And then we could check our answer like we did before. So condense, isolate, change to exponential, solve, and check. So let's try this with two examples down here. So log base 2 of x plus 6 minus log base 2 of x equals 3. So notice that little trick wouldn't work here if I added log base 2 of x to both sides, because I would have this 3 adding on the outside. So that doesn't work here. So instead what I want to do is condense. So I have subtraction between these two. So I'd have log base 2 of x plus 6 over x equals 3. Then we would want to isolate the logarithm, which it already is. And then what we're going to have is, so the value, this is how I kind of do it, is that value inside the logarithm, that's going to kind of fall out. So x plus 6 over x equals, and then base 2 exponent of 3. All right, so x plus 6 over x equals 8. Multiply both sides by x, so x plus 6 equals 8x. Subtract 1x from both sides, so 6 equals 7x, x equals 6/7. And then we could check our answer by plugging it into the calculator. Let's go ahead and walk through that together to make sure we have the ability to check our answers. Again, with this base 2, we'll need to use a change of base formula. So we're going to have log base 2 of x plus 6. So I'm going to go natural log of x, which we just found is 6/7, plus 6. And then for base 2, I'm going to divide by natural log of 2. And then minus log base 2 of x. So natural log of x, which is 6/7, divided by natural log of 2 for the base. And our calculator showing us a value of 3, which is what we had on the other side of the equation. So it gets a little messy with that change of base formula, but we need to use that to check. All right, log base 5 of 4 plus log base 5 of x minus 3 equals 1. So with this one, we have addition between our two pieces, so when we condense, we're going to multiply. So log base 5 of 4 times x minus 3, so I'm going to go ahead and just distribute 4 in, so it'll be 4x minus 12 equals 1. Isolate the logarithm, which it already is, and then we're going to change to exponential form. So the value just kind of drops down, 4x minus 12 equals base of 5 exponent of 1. Add 12 to both sides, so 4x equals 17. Divide both sides by 4, so we're getting 17/4. And let's go ahead and check our answer. Again, that change of base so that we have a base of 5. So we're going to have natural log of 4 divided by natural log of 5. And then plus natural log of x minus 3, so 17/4 minus 3 over that base of 5. Natural log of 5. And there's our value of 1, so it checks out. So that's how we solve logarithmic equations. If you need to condense it first into a single logarithm, isolate that logarithm, and then switching to exponential form will help us solve for anything that's stuck inside the logarithm.